Hi, and we're live. Welcome everyone to this week's Dapr Community Call. My name is Cecil Phillip, and I'm one of the community managers here. And if this is your first time coming to one of our community calls, welcome. Definitely feel free to let us know inside of the chat and the comments where you're watching from, where is it that you call home. I'm on the East Coast of Florida, so that's where I am. And today we have a really interesting agenda for you today. Today I am joined with Elena, and she's going to be talking to us about actors and multi-talency and tons of amazing stuff that we could do with Dapr. And then we'll get into like some updates on the Dapper Day event that we have coming up in October, as well as our community show and tell. So again, definitely feel free to go ahead in the comments in the chat. Let us know if you have any questions at all. If you have anything that comes up, we'll try and get them answered for you live. And with that being said, Alana, I'm gonna give it up to you. So why don't we just start really quickly with you just letting folks know a little bit about yourself, who you are, and what do you do?
Of course. Hi, thank you for having me. I'm always very happy to talk about actors, so this is a great and exciting opportunity for me. I'm a software engineer at Dapr. I am a contributor to Dapr, an approver in the Python SDK, and yeah, just enjoying being part of this amazing community that Dapr is, surrounded by amazing engineers, if also I might add.
Nice.
Should we already dig in? Would you like to give some more introduction, like context, or should I go ahead and just dive in?
I think that was really good context. No, I think why don't we go ahead and just get the session started, and then what I'll do, I'll be monitoring all the chat and the conversation. So if anything comes up, we could definitely talk about it later.
Perfect. That's great. So from my point of view here, the context is that multi-tenancy came into Dapr Actors in version 1.14, which has been out for a while now, I think about a month since we released it. Multi-tenancy itself actually is not this big thing that it's not a new feature. It's not something that we can talk about for hours. It's actually a little part that we added on to actors. I say it is little, but it was actually one of the most requested features in actors based on the community. So in order for everybody to be able to be on the same page, I thought that I would go and explain a little bit of what actors are, how we use them, how they work in Dapr, because they can be really abstract, the concept. It's not something very simple that you see, okay, this I know how this is used. You really have to understand them a little bit better in order to see them, to recognize the actor pattern and an actor use case when you see it. So let's start with maybe a little bit of theory. If you want to describe actors, we could say that they are a basic building block in the domain of concurrent computation, and they have three main properties. So they have behavior, they can have state, and they can communicate with other actors. Those are the three main things that actors are based on. Now, you're probably thinking two things. The first one is maybe, well, gee, yeah, thank you. That's a very specific definition. Now, for sure, I understand actors, and yes, I know that's very abstract, but we're gonna get there. I'm gonna explain them in more detail. And maybe the second thing that you're thinking, or at least the second thing that I was thinking when I started looking into actors is, well, this sounds awfully a lot like object-oriented, the object-oriented programming model, right? So behavior, state, exchange messages, communicate actually to other objects. Yeah, is this the object-oriented programming model? Well, indeed, maybe we can make some analogies here. I'm going to use Dapr specific terminology where we have we differentiate actually between an actor type, which we can compare to a class in the object-oriented programming. And then we have an actor ID, or an instantiated actor, that we would compare to an object. But the difference here between this comparison of actors with objects is in the scope. So while an object from OOP exists in the context of a single process, right, or a single node, right, the scope of an actor would be the whole distributed system. Okay, so imagine a class and an object, but it can exist across multiple nodes, and it is kind of the same thing. It's still the same actor type. Some other properties of actors, and I think probably the main one, is that an instantiated actor and an actor ID is going to process requests that it gets sequentially and in isolation. When I say isolation here, I mean the I from ACID, right? So what that means is there's multiple callers trying to invoke a method on an actor. They're going to have to wait in line. First one completes, and then the other one can go. And this is actually a really, really big deal. The isolation that I mentioned, that is the I from the ACID acronym, which is we're talking about the transactional properties of databases. That's actually, we're playing in the same domain. So the isolation that the databases guarantees the same isolation we're talking about here. Okay, more properties. The state of an actor can be persisted in a state store, configurable. You can schedule work to be executed periodically. So you have timers and reminders. They have different details. We're not going to go into that, but it's pretty cool that you can schedule some work. Say, okay, run this task on an actor every day at 5 p.m. So that works. And then another great thing here, which is the part of Dapr, not necessarily characteristics of actors, is that, well, the Dapr SDKs allow you to work with actors, which means you can use your own language. Currently, we support actors in the 5 main SDKs: C#, Java, JavaScript, Python, and Go. Okay, so fun fact here, when I started learning about actors the first time, I kind of saw, okay, I see, I think I understand. It's like, maybe you can imagine them as objects, and I was saying, oh, well, I like to explain actors and objects. I thought, wow, I discovered a nice analogy. I'm going to use this to explain actors to people, to make them a little bit easier to understand. And then as I continued the research, I saw, well, this is not a coincidence. In fact, the father of object-oriented programming, and the father of a few other things, by the way, in computer science, he's a really big deal in our world. All of us, we owe a lot to him. He coined the term object-oriented programming, and he was inspired by the actor model. And this is a quote from a book, a Riley book. But then when I continued my research, I actually saw that might not be necessarily true. It works great for my story here, but it may not be completely true. In fact, Carol Hewitt, who is the inventor, let's say, he's not the only one who worked on the actor model, but in fact, Carol Hewitt got also inspired by the message passing in the small talk language. So I don't know what's true here. They were living and working at the same time. Ellen Kay is still alive. So they were working around the same time. They were communicating, corresponding, and they were probably just influencing each other. But both of them really liked the message passing model. Okay, so let's see how all of this works in Dapr. You probably know if you're here in this community call, you probably already know a little bit at least about Dapr. You know that it runs as a sidecar. This is the sidecar model. So it runs in the same pod as your application. different container in the same pod as your application. The actors are actually something you write in your own application. You define the behavior, you define what the actor needs to do. You write them as classes in your application. We provide, or our SDKs provide an interface you need to kind of satisfy. There's a few things, but other than that, you're quite free to do to program the behavior that you need. So then the application, with the help of the SDK, creates these actors. When it has to register them with Dapr. How does it do that? It's the implementation detail. You don't really care about it, but it basically creates a little endpoint that lists all the actor types. Again, actor type is like the class, let's say. Actor ID would be the object. So it shows which actor types it serves and communicates that to Dapr here. Okay, so then Dapr becomes aware of which actors are present on this application. If that application scales horizontally, and then we have more actors, we have more bots, first of all, we have more actors, then one of these two, let's say, like if we are talking about this case specifically, one of these applications is going to serve a subset of the actors, and the other one is going to serve the other subset. And this is great. Then if we have an application who wants to communicate to one of the actors, I mean, the great thing here is that, first of all, we can horizontally scale. This is a big deal, okay? There's more things. We're going to go into this. How does this work? How do we decide who goes where? And all of those interesting stuff. But the main thing is we can scale. If our system gets to the point where we need to, where one pod is not enough, we can horizontally scale. That's the key point here. So then how do the invocations work? An application that needs to call an actor talks to Dapr, which is the local Dapr here, the local in the sidecar. And it says, well, I want to talk to red actor 2. Dapr is going to check, and again, this is the implementation detail. Well, do we host that locally? No. Well, okay, I'm going to go and find it in one of these sidecars, and then it connects to Dapr, and Dapr talks to this Dapr, and then this Dapr talks to this application and invokes the actor. The logic executes here inside of the application. Great, but how does this Dapr know where actor 2 lives? Why not here? Why not in another sidecar? Well, there's this thing called the placement service. The placement service is part of the Dapr control layer. And it basically, can we call it the heart of the actor subsystem? Maybe. If we compare it to etcd, that's called the heart of Kubernetes. Well, maybe we could do that because the placement service hosts the information about which actor is hosted where, which actor ID, actor type, and actor type is hosted where. Every Dapr that hosts an actor type, so it will be this and this and this pod here, is going to send the information about the actors it hosts to the placement service. So this one here is going to send, well, blue and red are with me. I'm pod number 1, let's say. Blue and red are with me. Dapr, this one's going to say, well, blue and red are also with me, pod number 2. Pink and yellow are with me, pod number 3, and so on. So the placement service gathers all of this information and then disseminates it to all the other pods, all the other Daprs that need that information, basically that use the actor subsystem. Okay, so that's how this works. This is way oversimplified way of explaining it. By the way, this is the placement table that the placement service keeps, and this placement table is the thing that gets passed around from the placement service to all the Daprs. Now, it's very simple if you describe it like this. In fact, it can be a little bit more complex than that because this table needs to be consistent, right? We cannot have a situation where this pod is going to have one version of this table, and this one is going to have another one. If that happens, we might actually get into real trouble, and it will even break some of the requirements of actors, like the isolation. So keeping this consistent is a very interesting thing we do. And the placement service, by the way, can be a single service, but it's in production systems, it should be a cluster. Usually we have 3 placement services running for high availability. Because if the placement service goes down, all the Dapr sidecars simply delete this table, because they say, well, if I don't have the latest table, the placement service is down, so I don't have the latest table, I'm just going to stop everything. I'm not even going to try to do it. I just delete this table, and I have no information about where any actor lives. And actor calls simply stop. They start airing out. Okay. Well, yeah, this can be a cluster. We talked about that. If you're interested about some implementation details, how we do maybe leadership election under the hood, we use a Raft server. So we base it on the HashiCorp Raft library. Pretty interesting stuff. And if you ever want to talk more about it or even contribute, just come to the Dapr repo or talk to us, talk to me on Discord. Okay. So now, once these Dapr sidecars have these tables, they can communicate with each other. So they can invoke methods on other actors on other pods. Now, but why all this? Why add all of this complexity? Aren't objects simpler? I tried to kind of explain this already in a way, but maybe we can summarize it. So the key 3 things, there's more, but the key 3 things that I would say we have here are, so we have concurrency. Each actor operates independently, so they don't have to wait on each other, and we're talking about different actor IDs here. So that's a big deal. Scalability is the other big deal here, and the distribution of actors. So knowing which actor is going to be hosted where. We cannot have repeated actors. We cannot have the same ID hosted on 2 pods. If that happens, how are we going to lock it? I guess we could, some distributed locking or something, but that becomes a very complex problem to solve. So the distribution of actor IDs on a single pod has to be really well done in order for everything to work properly. And then fault tolerance. So actors are designed for a distributed network. Okay, so they know that there's going to be latency. They understand that the network is going to maybe be faulty, be glitchy. They understand pods are going to crash. So if one pod is going to crash, everything's going to get rebalanced simply. If actor 3 was on pod 2 and pod 2 crashes, pod 1 is going to take over that actor 3. So all of that is done automatically, and I find it beautiful. Okay, so let's now put all of this into an example, because I think it might be easier to follow. Let's have, as an actor, let's have a smart light bulb. Okay, we're going to have this little bulb here. This is an actor. This actor is controlled by some kind of server that can turn it on and off, but who actually turns it on and off is a human that just something on their mobile phone. So then the mobile phone connects to some kind of a backend application that then invokes that actor on a different server. There's storage, of course. There's the placement service that disseminates the placement table, and everything that we already talked about until now. So, but now what happens if we have a system with millions of actors? Having a million actor on one pod is actually nothing out of the ordinary. We have seen cases like that. What if we have 100 million? So the point is, what if we need to scale, right? So then what if we have millions of users that are want to control these light bulbs at the same time? As we said, horizontal scale is the key here. So instead of single applications, we need to multiply them in a way and make this a true distributed system. So then if users want to control maybe this light bulb here, they have to go through this server. So when someone connects to this server, they're not going to be able to control this light bulb. They have to. They can only control these three here, for example. And then how are they going to know? Well, they have to know because the placement service send them the placement table. So if this person on their mobile phone wants to turn this light bulb on, Dapr is going to know because it has that information. Okay, well, how do you interact with actors? It's a very simple API. We have method invocation. You can save the state, get state, and create actor reminders and actor timers. Okay, so instead of doing all that locking information and rewriting it over and over again in your projects, in your code, between languages, maybe even, you don't have to do any of that. The locking and the isolation is done for you. The distribution is done for you. The actor rebalancing is done for you. So in terms of, pod crashes, all of that is covered by Dapr. And so all the complexity, we do it so you don't have to. And now, finally, we get to the namespacing part. So basically, before 1.14, all of these Daprs had information about all of these actors here, all of these light bulbs. And as you're already guessing, this can be an anti-pattern depending on what you're working on. But there are cases where actually you can't have this guy know about this actor here. So that's why in 1.14 we actually introduced namespace separation, where we isolate the actors per namespace, or we can also call this full dependency. Like if you imagine that maybe you have a cluster in a company, and then namespace 1 and namespace 2 actually represent organization A, organization B, or department A or department B in the company, or maybe even staging and production environment. Yeah, that's a very common case we also see. Sometimes, or staging and development, maybe that's safer. So with this namespacing now, people can use their clusters a little bit more efficiently. Okay. So let's see a little demo. It's really nothing fancy. As you see, the feature is just splitting this up. So I tried to add some color and flashing lights or blinking lights to make it a little bit more interesting. So let's look at some code first. I guess if you want to see the setup, okay, this is the GitHub repo. If you want to check it out. So in the setup script, we basically install Dapr. We create the namespaces. Then we build the app images. We load them in Kind. I'm working with Kind here. We install Redis. This is just setup stuff. And then we deploy the two applications. We have a client and a server application. We are working exactly with what we were showing before, the same example. And then we I just brought forward the services here, and then we can show how that looks like. So, okay, so these are the two clients in two different namespaces, and these are the like servers here. Let's see, they represent what's happening. So if we just turn off the living room light, only the living room light in namespace 1 is turned off. This one is not moving. And yeah, now we turn this one on. This one is on. Bedroom. And that's basically it. We just want to show that we have the same actor type, same actor ID. This would be the ID here. This is the living room. The actor type is smart bulb actor. But they are installed in two different namespaces, and we have a nice, clear separation. And the last thing I wanted to show here is maybe we can look at the actor code a little bit. So I mentioned that you can write your actors in your own application, in your language of choice. And this is how that looks. So there's a few methods that on activate and deactivate, something that the SDK provides, like receive reminder, create reminder, set timer. So there is we have to satisfy that interface, and then you can create your own methods. So like set status and get status, the status being the status of the light bulb. So the actor is a smart bulb actor. It has to implement the interface, which is defined here. We simply define the methods that happen, and then from the application, we simply call it like this: set status, and we set it to true or to false, basically turned on or off. If you wanna go into more details of this demo, you can go ahead and check this GitHub repo. And other than that, well, any questions?
Sorry about that. I was trying to press the button. It was not doing. The button was not doing what I wanted it to do. We do have a couple of questions that are in the chat, so I'll grab those for you really quick. So this one's coming from Waldo, and he's asking, so does the placement service ever do any rebalancing to ensure instances aren't using more resources than others?
Yes, so that's exactly. And the placement service used to do the rebalancing on the placement side. We actually did change that. We did make it a little bit more efficient in 1.13. So now the rebalancing is not something that's done once and then we follow that. It is actually, we just follow an algorithm. It's just a consistent hashing algorithm. And we move the calculation instead of being it on the placement service, and then we disseminate the data. That was really big, like we were getting really big messages there, so we tried to optimize that. And since it is this deterministic hashing algorithm, we do use a deterministic hashing algorithm for the ring hash. We move that computation on the Dapr side. So yes, in a way, yes and no. It's not the placement service that does the rebalancing. The rebalancing is done actually kind of dynamically on the Dapr side, but yes, we definitely do that.
Gotcha. And then there's no way. No, this is my question. There's no way to customize how placement happens. Like, is there? Can you plug in like your own placement strategy or anything of the sort, or is that not something that folks can do today?
No, right now we don't have that. The placement is only follows the this consistent hashing algorithm. It is something that we have seen, by the way. It's not the first time I hear this request.
Yeah. Okay. And then looks like Wood has another question. Sort of fast. So can you get a list of service, or can you get a list of active or dormant actors? And if so, can you do it by namespace?
I don't think we have an API for that. Okay, so the virtual actor
model. Yeah, I'm not sure
that,
either. I don't think I've ever seen that.
Yeah, I think maybe the terminology should be a little bit clearer here, because let's say the original actor model is not exactly the same with the virtual actor model that we are using. So you don't have to kind of manually activate actors in Dapr. That kind of happens dynamically. Okay, Yaron, I see Yaron just answered.
Yeah, and it looks like Yaron is here in the chat.
Yeah.
Yeah, and it says like we have a metric for the active number of actor instances, but it doesn't come with their names and things of that nature. So there you go. So hopefully that answered your question. Obviously, if you have any more, or if you need any more clarification, definitely feel free to let us know. We had one other question in here. This question was not related to actors, but I'll pull it up anyway. So Tom's asking, is there a Dapr Backstage plugin in the works? So for folks that are curious, Backstage is like an open source tool for creating developer portals. You have dashboards, and you can have all your APIs and your assets, right? That you can kind of index them in a space. I don't think that there's any support or announcements around that. Maybe there's someone in the community that's building one, but I don't know anything about any work from the Dapr team being done around Backstage. Alana, I don't know if you have any comments about that, but I don't think that's something that I know that
No,
is
it's not really
is being
something
worked
we've talked
on.
about. But since Yaron is here, maybe he can provide a more long-term vision. It's definitely not something that's coming in the next few months.
Yeah.
Unless someone from the community contributes it.
So since you've been talking about since you've been talking about actors, one of the things that I know folks have always asked are, outside of devices and fleet tracking and some of these types of things, what are some other use cases? Like, what are some business, other business use cases you've seen folks use with containers? I'm sorry, use with
actors.
Use with actors. I'm sorry, I've been doing containers all day today. Using with actors and particularly with Dapr actors itself.
Well, if you want to talk about Dapr actors specifically, the most interesting use case we have is running on the International Space Station. So they use some kind of, let me see if I can get this right, I guess some kind of machine learning model or computer vision model to scan their gloves they use for spacewalks. So when they have to go out in actual space, with all the radiation and the cold and you have to be well protected. So you have to have good gloves. So they use some kind of model to examine the photo of a glove and to find problems with it, because that manual process used to take a long time before, and now they're using Dapr actors for this. I think this is probably the most interesting and cool, I guess, use case that I know about. But some other use cases that could be very good candidates for actors are could be session management. Make them sticky. Could be bank accounts. Even it is tricky. Okay, so please don't go ahead and just implement actors now right away. They are things that should be considered, and when we talk about money and finances, we always have to really be careful. But in theory, this is a very very good use case.
Yeah, thank you for sharing that, because outside of just the Dapr aspect of it, right, I find like the actor pattern itself is something folks are always like, well, what do I do with it, and what is this, and what are some use cases that this really benefits from? And one of the things that I think I love about actors in Dapr is the fact that our actors, or our actor framework, is not dependent on any one language, right? So you can have multiple languages all within that quote unquote actor application. You know what I mean? Whether it's Python and Go and .NET and Java, which kind of makes it really flexible, right? And so now with that flexibility, it's like, oh, what can I do with this, right? Like I have a hammer and I'm looking for a nail. Like what can I do with some of these types of things? So definitely thank you for sharing some of those use cases.
Of course.
Here's a question. This one came in from Roberto. Roberto is asking, I'm working on using Dapr actors as AI agents, LLM based. Have you seen an implementation of that yet? So I guess he's asking, have you seen folks using actors and LLMs together in any types of interesting use cases?
I haven't, but also maybe I'm not the best person to ask about this. We have Yaron in the chat. Maybe he would have a little bit more insight on this. At least I haven't seen it. I'm an engineer, so more GitHub based. In GitHub issues, I haven't really seen that pop up. But if Yaron and Arthur have seen anything, yes, please do comment. For context,
yeah, I haven't seen anything in that space either, but that would be.
Sorry, I think we have a lag. I was just going to say that for context, Yaron is the creator of Dapr, so one of the people who started all of this.
Hi, Yaron. Yaron's in the chat, so he's in here answering a bunch of questions for us. So, yeah, folks, if you have any more questions, feel free to go ahead and drop them in the chat. But with that being said, I think, Elena, thank you so much for coming on. This was great. I think you shared a lot of great information with us. And I know folks are always going to ask, where's the demo? And so obviously you have the link to the demo right there on the slide. So for folks, if you want to head over to the Diagrid Labs account on GitHub, you can go ahead and pull on this demo. You could try it out yourself, and then you can see, how to use, or, what the implementation of what Elena showed us today looks like. But with that being said, I'm going to switch over to my screen now. So give me 1 second. I will do that because the buttons don't like to button today for some reason. And we'll give you a quick update as to what's happening with Dapr Day. Now, for folks that may or may not have heard about this yet, but Dapr Day is actually happening in October. It's going to be on October 16th of this year. And we'll be celebrating 5 years of Dapr. Now, it doesn't feel like Dapr is that old. It's still really young, but it's been 5 years since the first release and announcement of the Dapr project. And so we have a really amazing agenda for you. Tons of folks from various companies and showing us different use cases and things of that nature. And we are blessed to have Mark Rasinovich and Joe Beta there. They're going to be our keynote speakers, our opening and closing keynote speakers. So definitely going to be a really fun, action-packed day. If you want to know where to go, I'm going to come out of full screen really quickly. Yeah, if you head over to the CNCF website, go ahead and you can, it says log in to purchase. I promise you there is no money involved. This is a free online virtual event. So even though it says purchase, you don't have to spend any money. But feel free to head over to the website. You can go ahead and register. You'll get calendar invites and all of these types of things. And then on this same page, if you scroll down, you'll see the agenda about all the sessions that are there, the topics that we'll be talking about, all of that types of stuff. So our agenda is out, our registration page is up. So definitely feel free to go ahead and register for Dapr Day, and hopefully we'll see you all in October. Now let's go through our show and tell really quick. We do have a couple of blog posts from our community. One talking about closer look at Dapr components. This is a really fun post. I believe this one's on Medium. And the author talks about really like looking at what are some of the different components that are available, how do you configure them, what are some of the potential use cases for like applying these components. So I think that was a really good one. Definitely feel free to check that one out. And then Mustafa and Mark, Mark is one of our other community managers here. They wrote a post on the AWS open source blog that talks about how to expedite production ready distributed application development with Dapr on AWS. So if you're an AWS user and you want to know how to plug in Dapr into your application, into your architecture, definitely recommend you checking out this post. Has lots of samples and diagrams and things of that nature that you could definitely pay attention to. And coming up next, as soon as this loads, so we have a couple of videos, and this thing likes to autoplay, so I'm going to stop that from doing that. But we have a bunch of videos online. Folks, around the community talking about Dapr, talking about Dapr and container apps, enterprise level Dapr, and then again, how you can deploy Dapr, your Dapr applications to different places. I really don't like this autoplay. We gotta figure something else out about this. And if we head over to social media, we have tons of folks on Twitter, on LinkedIn, and all these different places talking about Dapr, folks that are sharing their projects and talking about like some of the really cool and interesting things that they're doing with the Dapr project. Now, for those of you that are still here with us, if you would like to get involved, if you contribute, blog posts, or if you do presentations, if you even contribute to the documentation, we have these hollow pin badges that you can earn. Now, I have a couple of hollow pin badges, but I gotta collect them all, kind of like Pokemon. Like I want to get as many badges as possible. So if you're interested in collecting badges, definitely feel free to head over to github.com/dapr/community, and you can learn about like all the different ways that you can contribute to the Dapr project. Even if you're interested, you could come and present at one of these community calls if you'd like to. If you have an interesting project or something that you'd like to show off, maybe even how Dapr is being used in your company, definitely feel free to let us know, and then we can, get you a part of the process. And maybe you can get a presenter badge, which would be great. And even just for watching, if, for those of you folks that don't have one yet, you can scan this QR code. I'm going to leave this up on the screen for a second. You can take out your phones or cameras or whatever devices that you use, and you can put this on, scan it with your phone, and you can get a free community badge just for being here and just for supporting the Dapr project. So hopefully y'all could go in and grab one of those really quick. And with that being said, here's some really fun resources for folks of you that are, again, if this is your first time here, if you're new to the Dapr project, if you're Dapr curious and you'd love to know what are some of the things that you could do, definitely make sure you head over to dapr.io and check out our documentation that's there, as well as our YouTube channel, which if you're watching this, probably watching us on YouTube now, but feel free to subscribe to the Dapr YouTube channel. And we have, quick starts. We have, social medias on Twitter, on LinkedIn, on, we have Discord channels and all types of stuff. Even going back to Tom was asking some interesting questions earlier. Tom, if you're, if you'd like to dive in and, maybe help contribute to that backstage plugin, or even just kickstart that conversation, definitely recommend you head over to the Dapr Discord. And hopefully we can find some like-minded folks, some folks that are interested in doing that as well. And maybe you could, put together a nice little team of folks and work on some interesting stuff together. But other than that, folks, again, thank you so much for being here. I hope you join us for the next Dapr Community Call. We do these every 2 weeks. And again, if you head over to github.com/dapr/community, you can actually see the schedule of who's coming up, when the community calls are actually happening. And if you're interested in particular topics or anything of the sort, feel free to go ahead and join the discussion within the issue for that particular community call. We could try and get that handled for you. Alana, anything you want to say before we leave? I don't want to say final words. Final words sounds a little morbid, but like any calls to action or anything like that for you before we go?
Well, as an open source contributor, I guess all of us, we have probably one single call to action is come and send your contribution, reach out to us if you need help. We're very friendly and friendly to newcomers to the project. So I know sometimes it can be scary, intimidating to start with something as big as Dapr runtime, the core itself. So maybe come to one of the SDKs in your favorite language. Just reach out, check the issues, the good first issue labels, and talk to us on Discord. And we're gonna help you get your first Dapr contribution in.
And that's a good point you bring up too, because also if you head to the Dapr organization, there's a project in there, like a GitHub project, and folks could look and see, what's being actively worked on, right? So if you're curious about what's going to be in Dapr 115, any future releases, anything of the sort, definitely feel free to head over there. You can take a look at those, or again, open your own issues and start a conversation about other interesting things that you'd like to see. But again, folks, thank you all so much again for coming. We are at the end. See you again in 2 weeks. And thank you so much for joining us on this week's Dapr Community Call. All right, everybody, take care.